Hello my fellow chemilites. Today we are going to be learning how to name organic compounds like alkanes. Now, first of all, organic compounds they had common names or perhaps you say trivial names. But these trivial names they were not sufficient. Do you know why? Because we noticed that organic compounds started becoming wider and becoming broader and becoming more vast. So these trivial names were no longer sufficient. Then a group of scientists, the International Union of Pure and Applied Chemistry, came together to come and make a decision on how they'll be able to be naming all these compounds. That is how we got our IUPAC naming of organic compound. Alright, so now let's just dive into how we can be able to name organic compounds in the IUPAC way. Alright, now there are rules and there are three simple rules which shouldn't be difficult. First of all, the first rule is to identify the longest carbon chain. That's the number one thing you do. Anytime you see an organic compound, identify the longest carbon chain. Secondly, identify the type of bond. That time you will, like as we are doing we want to name alkanes now, you have to identify, you have to know if it's an alkane or alkyne, and that depends on single bond, double bond, and triple bond. Alright. Then lastly, identify the substituent. After you have done these three things, trust me, naming organic compound will be easy. So let's dive straight into that.
Alright guys, now fast and quick. Now look at this. This is the table we use in naming alkanes. Now, if you have one carbon, we use met. If you have two carbon, we use et. We have three carbon, we use pro. We have four carbon, we use but. We have five carbon, we use pent. Like pentagon, right? Then six hexagon, you get now. You getting it. Then seven hex. Eight octagon, you get it. And nine non and other egg. So you get the whole point. If you, I believe most of us are familiar with this, so just have to know it. Then you now add the suffix you get. After getting the prefix, you add the suffix which is an. These are our suffix. Then this will be our prefix. You get everything here is our prefix. So it will now be like methane, ethane, propane, butane, pentane, hexane, heptane, and octane, nonane, and decane. So we just have to move into identifying how we can put this into practice.
Alright guys, now take a look at this. If you notice, it can be actually funny, but everything here is the same. Everything is the same. Now, before you name any organic compound, first of all, look at it. If you notice, everything here has what? 4 carbon. 4 carbon atom. Now, so let's go to the simplest, the one we are most familiar with, which is this. This one, we have 4 carbon and our hydrogen are balanced. Now, because it's 4 carbon, if you like from the table I showed you before, you know 4 carbon is represented with what we call both. Now, if you look at the bond, a single bond, which means is an alkane, which is what in, you will now represent it with in. So therefore, we'll now call this guy what? We'll now call this guy butane. It's as simple as that. As I told you, the longest carbon chain, we've counted it to be 4. After that, we look at the bond. Though this one does not have substituents, so we don't need that rule. So third rule, we don't need the third rule. So now we have gotten the name of this to be butane. Now looking at this guy, let's look at this guy. This guy looks a little bit so funny, but actually it's the same with this guy. If you count, this hydrogen has what? Look at it. This hydrogen has what? 3 hydrogen. And this carbon, sorry, has 3 hydrogen. This carbon has 3 hydrogen. Now 3 hydrogen, 3 hydrogen, 2 hydrogen, 2 hydrogen. So this guy is also called what? It's also called butane. Okay, now let's look down. Looking downwards, it's the same thing. This guy is also called butane, but it's arranged in a funny structure. You know why? Because due to the single bond, there is a rotation of atoms. So the atom can rotate and change shape at any time, which is why this guy looks like another compound, but actually it's also butane. If you are doubting, count the hydrogens. See 3 hydrogen as we counted here, 2 hydrogen, 2 hydrogen, and 3 hydrogen. So this guy is also butane. Now looking at this guy, fun fact, he's also butane. No need to confuse ourselves. 3, 2, 2, and 3. Looking at the first carbon chain, longest carbon chain, no matter, it doesn't have to be horizontal. You don't have to count it like this. You don't have to count it like this. Sometimes the longest carbon chain can be zigzag. So, which is why this guy is also what called butane. Take note of all this. Now, finally, this guy is the most weirdest. But fun fact, this thing is butane. But wait, how do we know it's butane? There is a representation of alkanes and an alkyl group. We can represent them in what? Strokes. This guy here, every sharp point is a carbon atom chain. So now, and we have 1 carbon here, 2 carbon here, 3 carbon here, and 4 carbon here. 4 carbon is what? But. And we know it's a single bond. Obviously single bond, because there's no double line and double stroking. So it's obviously a single bond, which is why we can call this guy butane. Now, finally, let's move over to the one which has a substituent. Okay, so now as we look at this, first of all, we look for the longest carbon chain. This one we'll use the 3 rules. Now we count from where? Don't get confused. We can't count from here. Do you know why? Because of the substituent. We consider the substituent first. Now, looking at this, we can see that the substituent is closer to this side. So let's count from here. Okay? So counting from here, we have what? 1, 2, 3, 4. We already know it's butane. So, but the substituent is here. How do we now know how to name it with the substituent? We say 1, 2, 3, and 4. The substituent is in 2, the second carbon atom. So we have to name it what? 2 what? We don't know the name of this substituent here. But now, from our table, we said what? We said 1 carbon atom is what? Methane. But if 1 carbon atom is losing an hydrogen, it will be called methyl. That is where the methyl, that is how we know the methyl group is minus 1 hydrogen from a methane, you get methyl. If you minus 1 hydrogen from ethyl, ethane, you get ethyl. Okay, that's how we know it. So this guy, I have identified this guy to be methyl. So now we name him 2 methyl what? 2 methyl butane. Okay guys, let's look further into more difficult ones. Now looking at a more complex diagram. Now I don't want to like confuse guys too much, so I remove the hydrogen so that we can see the carbon chain properly. Okay, let's start from this guy. Now, from the look of things, it's obvious where the longest carbon chain will be here, right? So let's count from this side. No, we can't count from that side. We have to count from where? We count from this side. Why? Because here is closer, right? 1, 2. But here we have to have 1, 2, 3. You get it? So it's very important to note the substituent, the position of the substituent. Okay? So now, counting, we have to count it like this: 1, 2, 3, 4, 5, and 6. We now know that this compound is what? Hex. 6 is hex. 7 hex. 8 occ. As in the table. Remember, don't forget, make sure you put the table in your head. Don't forget it, alright? Okay guys, now since we have identified the longest chain here, what do? We have to identify the bond. Obviously, from the look of things, it's a single bond. There is no sign of double bond or triple bond here. So now what do? We now know it's an ane, it's an alkane, okay? So now, the last and final thing, we identify the substituent. The substituents are very clear. We have what? Methyls here, alright? There's a missing hydrogen. I told you, like, every methyl, every alkyl group has a corresponding alkane. So you just have to remove 1 hydrogen from an alkane to get the name of your methyl, alright? So, okay, your alkyl group, okay? So now, finally, we know that we have 2 methyl here, obviously. So, but we don't know the position here. So we have to count from our side. 1, 2, 3, 4. So we have what? We have the position of what? Let's claim this. So we have 2. Now, you don't put your dash. You have to put comma because there is another digit which is going to follow it. 2, 4 what? Then you now put your dash. Die. Now you have to use this. Die. Do you know why we put die? Because there are 2 similar alkyl group in this compound. There is 2 similar alkyl group in this compound. That's why we have to put die. If there are 3 similar, we have to use tri. If there are 4, we use what? Tetra. Okay, so we have only 2, so we use die. 2, 4 die methyl what? As I said before, 6 carbon chain, so we have to call it hexane. So it's as simple as this. Okay, now moving on to this guy. This guy is very simple. Let's look at it. So first of all, the longest carbon chain is obvious, alright? So we just count 1, 2, 3, 4, 5, 6. This guy is 6. Hex again. Now, but the branch is kind of funny. It's not like this one we have been getting. This branch is, now if we want to balance this branch, we have to balance him like this, right? So now if the branch, total of the branch is like this, C2H5, what is this guy? Now remember the second alkane family is what? The second member of the alkane family is what? Ethane, right? Ethane is what? C2H6. So the missing hydrogen there, what is now the name of this substituent? Obviously you know what to do, is ethyl, right? So now we now know that this guy here is what? Ethyl. Alright, so if we know this guy is ethyl, it's very simple. We just have to count from the closest. Here we have to count 1, 2, 3, 4. No, it's too long. 1, 2, 3. So we use 3 what? Ethyl what? Hexane. Okay? It's as simple as that. So moving over to this guy. How do we count this guy? Can be funny, right? Let's just count our longest chain. That's number 110. 1, 2, 3, 4. No. If you counted it like this, you are wrong. Totally wrong. So now, the longest chain, as I said earlier, must not always be the longest horizontal. So now let's consider this. We can consider it to be 1, 2, 3, 1, 2, 3, 4, and 5. You get it? So now we've allocated and we've gotten the longest carbon chain. The next thing our substituent is obvious to be what? Ethyl. So what do? We know that we now know the position of ethyl here is the third carbon, right? Even if we count from here, 1, 2, 3, 1, 2, 3, it's the same thing. 1, 2, 3. So we know it's the third carbon. So we just have to put it like this. 3 what? 3 methyl. 3 methyl what? Hex. Abi? Sorry. 1, 2, 3, 4, 5. 3 methyl what? Pen. Sorry. 3 methyl pentane. Okay, it's as easy as that. 5 carbon, pent, 6 carbon, hex. Okay, that's it. 9, 10, then none and dec. Okay, it's as easy as that. Okay, so now let's move on to more complex structures. All right, guys. Now, finally, looking at this guy, it's quite so confusing somehow, but we have to find our way using our 3 rules. First of all, we identify our longest carbon chain. But from the look of things, we have to still take note of the third rule, identify the position or identify the alkyl group, which will be our substituent. Or it might not even be an alkyl group, it might be an inorganic. Sometimes you might not get this guy as this, you might get him as what? A halogen, like halogens like what? Halogens are represented with X. So we have what? Fluorine, chlorine, bromine, and what? Iodine. These guys here, the 4 of them can also be a substituent. So if you don't see this guy, don't get scared. We can also use halogens, alright? That are denoted with what? X. Okay? So now, moving forward, let's identify the longest carbon chain. Alright? So let's count from here because it's closer to the substituent. We can say 1, 2, 3, 4, and 5. This guy is the longest. Okay, fun fact. Do you know we can also count this guy from here? 1, 2, 3, 4, 5. It's still the same thing, but let's just pick here. Alright? So now, since we've gotten it to be 5, so it's obviously what? Pent. Okay? So now, we'll now write our what? Pent. Our second rule is what? Identify the bonds. The obviously single bond. So let's write it pentane. Now, finally, we have to add our substituents. Obviously, we have 2 substituents here which are alike. So we have to call what? We now look for the position of the carbon. We have it to be what? 2 and 3. So we can just easily say 2, 3 dash die. Remember this rule. You have to if there are 2, you use di. If there are 3, you use tri. If there are 4, you use tetra. Okay? Di what? Methyl. What? Di 2, 3 dimethyl pentane. It's as easy as this. Okay, guys. So now let's look finally at this guy. Now Looking at this guy, what do we do? It can be funny. Let's count like this: 1, 2, 1, 2, 3, 4. No, that's not our longest route. 1, 2, 3, 4, 5. I think this should be the longest, right? Fun fact: this guy is neither the longest. This guy is neither the longest. Let's improvise. We can say 1, 2, 3, 4, 5, and 6. So the rest has been giving us like 4 and 5, 4 and 5. But fun fact, this is the longest route. Okay, guys. So now we have this to be what? Hexane. Now we also identified that it's single bond. So let's just put our hexane first. Hexane. Okay, guys. Now looking at this, where is our alkyl group? Our alkyl groups are in the position of 3 and 4. So we can easily see what? 3, 4 dash what? Dimethyl hexane. Okay, guys.
Don't go. Baby, please don't go. Baby, please don't go.
See, let me tell you, you can never find a woman like